So members, today our chemistry we are going to look at what we call ionic equilibrium, and specifically ionic equilibrium is too wide, so I've picked out what we call solubility product, or what we are calling what? KSP. Now our idea is going to be on KSP, how we can calculate it, and then how we can convert the KSP into what we call the solubility. Remember, we have looked under the same topic, you looked at like Ka, Kb, Kh, and so on. My idea is going to be on KSP, because these questions are frequent. So, we are going to begin by defining KSP. You know properly that this one, as we are writing here, is the product of the concentration of the ions raised with their powers, or appropriate powers, of the balance now equation, or of the stoichiometric coefficients in the saturated what? Solution with the spiraling with the soluble. This one is crucial, spiraling with the soluble salt of that compound always must be ionic. And the temperature is also important. When you are defining it, temperature must be mentioned, and then the spiraling with the soluble salt. Once they don't appear, the definition becomes wrong. So that one can only be valid if it is being done at constant temperature, and is only applying to what you call solutions that are saturated, as well as the salt being spiraling in what? Soluble. So they can ask you, when does the KSP become valid? Now, the factors or the conditions, you mention the constant temperature, then you mention this part of the ready solution, and the salt being spiraling in what? Soluble. Remember, in the definition we are saying spiraling in the soluble must appear, temperature must appear, and the compound being ionic. Now, let us try to look at some examples now of the KSP now. When we have our salt like this one, that is lead 2 chloride. Lead 2 chloride, remember, is spiraling the soluble in water. So we are representing water with aqueous, HU. Then when you put this one in the water, since it's spiraling the soluble, we shall get now ions of lead, and then shall get still ions of chloride. Now, if you are going to write KSP expression, since we are saying product means multiplying. So we shall just come and say KSP of that salt, that is KSP of lead 2 chloride salt, is just equivalent to the concentration of lead 2 ions, aqueous. Concentration, you always represent them with that bracket. And that bracket should be written correctly, not the other normal bracket of mathematics, but this one, then times the concentration of chloride ions. We have concentration of chloride ions here, aqueous. You use the same bracket like that. But now we are saying you raise them to their power. Don't forget that. So this number, this coefficient in the front of the chloride will become the power of the chloride. There we have written KSP expression of that. Similarly, for this one here, we are going to say KSP of calcium phosphate, after writing the equation, is going to become now the concentration of calcium ions. Remember, we said you use that square bracket like that. Then powered by 3, because of the issue of the raising to appropriate power. Then times the concentration of phosphate what? Ions, like that, but also raised to appropriate what? To appropriate power. The power here is going to be power 2. Now from there, if you have, for example, silver oxalate, this is silver oxalate. After writing the equation, of course, when you put it in water, we are putting reversible arrows, because now we are at equilibrium. We have a forward reaction and a backward reaction. So here we shall get our KSP expression is going to be equivalent. The concentration of the silver ions here is our silver ions, like that. But remember, we have said we are using that bracket for concentration. Then times the concentration of oxalate what? Oxalate ions, like that. Oxalate ions. But we are saying you have to raise them to appropriate power. There is 2 here to work as a coefficient of this. So we are going to put it here to work as power. If this one we had a number, we raise it here, and so on. When we come here, this is calcium hydroxide also spiraling soluble. This explains why we are putting SS there, solid. Now here we are going to say KSP is equivalent, the concentration of calcium ions, like that. Don't forget this bracket. This bracket is paramount. When you write another one, you are misfiring the chemistry. Then times the concentration of hydroxide what? Ions. So hydroxide what? Ions. But we are raising them to power of what? Of 2. The water will be divided here. But now in our expression is here, we are ignoring the water. Remember, I've used the H here. I would have used the water there. But I'm putting H because I know I'm going to eliminate the water in my expression. Because we are assuming this water is in large what? Large excess. We are going to see it, giving it as an assumption as we are doing some calculations. Now let us try to work out this one. How can we calculate Ksp? Remember our topic is at calculating Ksp. Now when we come here to calculate, they're telling us to calculate the Ksp. Now what we are going to do when we are approaching this question, my friends, we are going to begin by writing the equation of the reaction. That is magnesium hydroxide. This is solid. Then to put reversible symbols to form magnesium ions plus the hydroxyl ions. But we are seeing there are 2 hydroxyl ions. Now, after writing the equation, we are going to write the Ksp or the Ksp expression. So we are going to say Ksp is equivalent the concentration of magnesium ions, then square bracket, don't forget them, then times the concentration of hydroxyl ions. But remember here we said you have to raise to appropriate power. This 2 here, we have to put it there. After doing that, remember we are solving our question. Now we come and see, we go and then we find what we call molarity. So we are going to find our molarity. But our molarity is going to be equivalent to the mass which is given. Because when you check that question you have, there is some mass given in grams per decimeter. So we shall get the mass given divided by the molar mass. So meaning now we have to find the molar mass of all of this one. So we shall come and say molar mass of what? Of magnesium hydroxide. Magnesium hydroxide is going to be equivalent. We shall get now the 24 for magnesium from the periodic table times 1, then plus the 16 times 2 from the periodic table still, then plus 1 times 2. And now when we sum everything, we are going to get what we call 58 grams per mole. Then from there, we are going now to find number of moles. We shall just substitute there that now our mass, which was given in the question, is 2.78. Then divide by our molar mass, which is 58. And then we are going to arrive to our answer. When you get your calculator, there is 0.05 moles. But remember, they want Ksp. So from there now we are going to relate. Remember we said like this, so we have to find concentration of magnesium ions. So when we are finding concentration of magnesium ions, members, we are going to base on the mole ratio. 1 mole of this one, when you look here, produces 1 mole of that. And then it produces 2 moles of hydroxide ions. Therefore, this means concentration of magnesium ions, since 1 mole produces 1 mole, is going to be equivalent to the concentration of magnesium hydroxide. So we shall get the other concentration which you have got this one. Remember, it is for magnesium hydroxide. Don't forget that. So it's going to become magnesium concentration, magnesium ion concentration will be like that, moles. Then from there we shall solve for the concentration of hydroxyl ions. Concentration of hydroxyl ions like that. When you go back to our equation, you find that 1 mole of magnesium hydroxide produces 2 moles of hydroxyl ions. This implies that 1 mole of this, since it is producing 2, to get the concentration of that one, we shall multiply by 2. So we shall get the concentration of magnesium hydroxide times the 2. When you multiply by 2, we get 0.1 moles still. Now remember, these are moles per dm what? cubed. Even these ones are moles per dm what? Per dm cubed. Then from there, we are going now to find what we call our case P by substituting our expression. So our case P now is going to be equivalent to the concentration of magnesium ions here, which you have already got as this, which is 0.05. So we don't repeat the other brackets which are square. We have already got it, so we use normal mathematical brackets. Then times the concentration of what we are calling the hydroxide ions, which is 0.1. But remember, the expression is having power 2. So we come and power here by 2. After doing that, we are seeing that our final case P is equivalent to 5 times 10 power negative 4 moles cubed, then dm power negative 9. Where are these units coming from? When you come back here, you will see that our units now, remember units are crucial here. If they are wrong, the answer is wrong. So we have here our moles dm cubed times our moles dm cubed, but these ones you have squared them. So when you apply mathematics of that one, we are going to arrive to moles power 3 dms power negative 9. I'm saying wrong units, the answer here is going to become what? Wrong. Then raising to appropriate power, don't forget it. Then we can start another example from there. Phosphate, this calcium phosphate members is this. Then they are telling us to determine case P. Remember we said we have to begin by writing equation. So we are going to begin by writing our equation here. That is calcium phosphate like that. And it is breaking down like that to produce the calcium ions. So now members, after writing our equation as you have written it there, then we write the case P expression. And our case P expression now we are going to say A. Remember now our equation here, you can see that our equation is not balanced, so we have to put a 3 there. Then we have to put a 2 there. Then we write our case P expression, so we shall get our calcium ions here, aqueous, then square bracket, then we power by 3, then we have our phosphate ions, like that, then powered by 2. The 2 is this coefficient, and the 3 here is this coefficient. Remember we said you raise to appropriate what? Power. But now this one, when you look at the solubility which is given, it's not like the first one here. The first one here, it was in grams. This one again, the man is tricking us, or the woman is tricking us by giving light. Already calculated here, we calculated because we had the grams, or concentration in grams per liter. Here now we are seeing their moles, but in 1,000 moles per decimeter. Therefore, the treatment we did here of finding moles, we are not going to do it here. We shall move directly with our molarity. So we shall just come and say concentration of calcium ions now. Concentration of calcium ions. But when you look at mole ratio, 1 mole of this one here is producing how many moles of calcium? It's producing 3. This implies that we shall get now concentration of calcium ion will be equivalent to 0.01, because 0.01 is for this one, calcium phosphate, all of it. So we shall get the 0.01 of the all calcium phosphate times the what? Times the 3. And now we arrive to 0.03 moles per decimeter cubed. Then when you come to the phosphate ion concentration, before we substitute into our expression, we are seeing that 1 mole of this one produces 2 moles of phosphate ions. Mole ratio here is crucial. We have multiplied by 3 because 1 was producing 3. Then here we have 1 producing 2. Therefore, we are going to say 0.01 times the 2 there. And therefore, here we are obtaining our 0.02, but still moles per decimeter cubed. After obtaining our moles per decimeter cubed, Now, we are going now to substitute into our expression. So we are going to say case P is exactly equal to the 0.03. This is now concentration of calcium ions powered by what? Powered by the coefficient here. Don't forget it. That is powered by 3. Don't confuse it here. After multiplying, you forget again to square, to cube here. After doing that, we shall set times the 0.02, but again we have to bring a coefficient, this coefficient. So we power again. Then from there, we shall want to obtain here, when you get your calculator, try to place your calculator there also as you are following me. Here my calculator is showing 2.7. I don't know what your calculator is showing you. Power 5, then times the 4 times 10 to power negative 4. Now, after doing that, then we pass. When you do the multiplication properly like that, we are going to arrive to our answer like that. 1.08 times 10 to power negative 8. And these are our units. The units from where we are multiplying them as follows here. Then we shall arrive to these units. Now from there I told you units are very, very crucial when you are doing any calculation. Then leaving this part, you can see properly what we have done. We can come to this one. Now when you look at this question, they are saying the case P of silver oxalate is this, 8 times 10 to power negative 2. And now they are telling us to convert it to what? To solubility. These two examples, we have been converting solubility to case P. Then this one is telling us to convert case P to solubility. So what we are going to do, we are going to sit to write the equation properly. We shall write our equation here as silver oxalate, like that. We said you can put HU here or you can just put reversible arrows. Then we are getting silver ions here, silver ions plus oxalate what? Plus oxalate ions. Then we are going to write, members, after writing our equation like that, then we shall come and then relate. We are going to relate the solubility, B, for example, solubility of the oxalate, that is silver oxalate, B, for example, X. So if solubility of silver oxalate is X, it means now here we have X ions, and even here we have X ions, but remember here we have 2, therefore here we have 2X. In simple terms, that is in line with the ratio. However, we can come and say now, the concentration of, remember our case P expression is like that, is equivalent, concentration of silver ions, like that, but raised to appropriate power of 2, then the concentration of oxalate ions, like that. Then from there, we are saying that now we can find a concentration of silver ions. Silver ion concentration is equivalent to what? To 2x. So 1 mole of this produces 2 moles of this one. But we are saying solubility for this is x. Therefore here we have 2x. Then we also get concentration of oxalate what? Oxalate ions here. And now this one is going to become what? X. Like that. Then we substitute into our expression. So we shall get case P is equivalent to this one here for silver ions, which is now 2x, but raised to appropriate power of 2. So there is a 2 there. Then times concentration of the oxalate ions there. Now after doing that, then we continue to solve our expression. So here what we are going to say now, we are going to bring in our case P here, because now we know it. So we shall say 8 times 10 to power negative 2 is equivalent to this now 2x power by 2, and this one is going to give us 4x squared because of this 2 times this 2. So we are seeing now times again x. So we are going to arrive to our answer as 8 times 10 to the power negative 2 is equivalent to 4x cubed. But remember, we are looking for the x alone. So what we are going to do, so we are going to just say, we are going to divide by 4, and we divide by 4. Dividing by 4, we shall remain with our x cubed is equivalent to 8 times 10 to the power negative 2 out of 4, like that. But remember, we want x is what we are saying is a solubility. So what are we going to do here? We are just going to get now the cube root. So we shall come and say that this one is equivalent. This one is equivalent to our x is equivalent to the cube root of 8 times 10 power negative 2 out of 4. So you can simplify as you want. Then my final answer here, I'm going to obtain 0.27 moles. So you can simplify in a way. Assuming it is not this one, let me try to guide you with these other ones. Assuming I have now these ones and I'm turning, remember we are turning what? Case P, we are turning it to solubility. Don't forget that. If, for instance, I have this one, we just write the equation like that. This one is giving me silver ions plus chloride ions, like that. Then we will just let, assuming this is the solubility is Y, the one we are looking for. Here you will be having Y, and even here you will be having Y. So we just come and say case P is equivalent to silver ion concentration, like that, times chloride ion what? Concentration, like that. Chloride ion concentration